In this problem, we have a 1500 Newton crate that is being pulled with a force of 400 newtons at 25 degrees above the horizontal. So I've drawn a free body diagram and given you the given information on the right side of the screen. There's the given. And on the left side of the screen, I have a couple of other equations that we'll need in a moment. Well, in all of these problems, when you have a force at an angle, you have to break it up into its components. So on the next slide, what I've done is I have broken this up into a vertical problem. So the force, the 400 Newton force that's at an angle, is broken into its vertical component of F sine theta. So in this problem, we want to find the normal force, the force of friction, and the net force. So we're going to start with this vertical problem to find the normal force. So it is not accelerating upward. Certainly it's a box being dragged or a crate being dragged along the floor. So I know that the net force is 0. So the normal force, which is upward, plus the component of the applied force, which is also upward, has to be equal to the downward gravitational force. Now let's put in numbers. I don't know the upward normal force, but I know the applied force is 400 newtons, so I have to multiply that by the sine of 25, and that will be equal to the weight of the object, which is 1500 newtons. Now, you always solve this part of the problem first, and if you solve that, you should come up with a normal force of 1331 newtons. Now, that makes sense because if I'm pulling up, the normal force should be less than the weight. Okay, now that I've done that, there's one other thing I'm going to do right now, and that is find the force of friction. I'll put that in this corner because it's really not part of the vertical problem, but the force of friction in the horizontal direction is the coefficient of friction times the normal force. So let's just find that here. According to our givens, that's 0.200 times the normal force, which was 1331 newtons. So we use what we found for the normal force to find the force of kinetic friction, and I got 266.2 newtons. And we'll need that on the next slide. Okay, remember what we found for the force of friction, 266.2 newtons. Okay, so horizontally, I may be accelerating, I may not be accelerating. Certainly, if I exceed the force of static friction and I exceed the force of kinetic friction, I will accelerate. So it is clear to me, not clear yet, but once I find out F cosine theta, we'll be able to figure out whether we have a net force here. And the force, which is the applied force, is the component of the applied force. The force applied is 400 newtons, so to get the component, I have to multiply by cosine of 25, and when I do that, I believe I get 362.5 newtons. So I'll write that on my diagram. And now it is clear that we are, in fact, accelerating to the right because the net force in this case is going to be 362.5 minus 266.2, and the net force I get horizontally ends up being 96.3 newtons. Now from that you could find the acceleration. But let me just make one comment here because you have to be careful. I know the weight of the object is 1,500 newtons. So the mass, to find that, I would take the weight, divide by the acceleration due to gravity. I'm certainly going to leave that one up to you, but it's roughly 150 kilograms. So you have to be careful when you find the acceleration to use the mass and not the weight. Hope this helped.